Hello, welcome to our discussion on section 4.2, ionic compounds themselves. And so we're going to look and see what they are, and then we're going to look at how to put them together and how to name them. So first of all, ionic compounds are positive and negative ions that we've put together. They have attractions called ionic bonds, and so that basically what that is, it's the attraction between the negative and the positive ends of these ions. Ionic compounds typically have high melting points, and they are usually solids at room temperature. And one example of an ionic compound is sodium chloride. We're familiar with sodium chloride as common table salt, but it's interesting because you take sodium metal, which is a soft metal that actually will explode if you put it in water. It's water reactive, they call that. And also chlorine gas, which we use to kill microorganisms in swimming pools and other water treatment applications. And you put those two poisonous things together and you make something that we can consume with our meals, and many of us too much. So sodium chloride is an ionic compound where we have put a metal and a nonmetal together to form an ionic bond. An ionic formula is basically going to have the positively and negatively charged ions that we're going to write together. It must be neutral in order to be stable. It has a charge balance, so that is that the total positive charge equals the total negative charge. And so in this, we write the metal first, and then followed by the symbol for the nonmetal. So metal, then nonmetal is how we're always going to write these. So when we write the formulas, okay, what we're going to do is we're going to look and we're going to say, okay, the magnesium had 2 valence electrons here, and chlorine had 1 valence electron. And so since we've got 2 here for magnesium, and we're going to need 2 chlorines to actually combine together. So what happens is that the 2 electrons leave the magnesium and are going to be transferred to the chlorines, giving the chlorines 8, which is the octet, and taking magnesium back down 1 level so that it has an octet. And our balance will be correct because we'll have a +2 on the magnesium and a negative on 2 of these chlorines. And so we have 1 magnesium and 2 chlorines. And so that gives us 2 pluses here, and 2 times -1 is 2 minuses here for an overall charge of 0. And so we write those as subscripts, saying that Mg, remember we usually don't put the subscript if it's just 1, and chloride 2 for magnesium chloride, because it takes 2 chlorines to hook up with the magnesium in order to make that a neutral molecule. So the subscripts in the ionic compound is the number of positive and negative ions that give the overall charge of 0. So if the total positive charges equal the total negative charges, that equals 0, right? And so that's how we maintain this neutral balance in these ionic compounds. So in the case of sodium sulfide, the formula tells me that I have 2 sodiums and 1 sulfur. So an S atom gains 2 electrons to become S2-. I know that by looking at where it is on the periodic table. The subscripts tell us that each ion is going to give the balance to the overall molecule. That is, that you have 2 sodiums, which are 2 pluses together, and 1 sulfur or sulfide ion, which is -2. And so 2 times +1 is +2, and 2 minus is 2 minus, and so +2 - 2 gives you an overall charge of 0, which is neutral. So what happened in sodium sulfide is that you had a sulfur with 2 electrons that could bind. You had sodium with 1 valence in its outer shell, and so in order for these to make a neutral compound, the sodiums each give an electron to the sulfide, giving it a -2 charge. And so the resulting is a neutral sodium sulfide molecule or compound. Same thing with Na3N. If you're going to put sodium and nitrogen together in a compound, nitride is a 3- because it's in group what? 3A? Nope. If nitrogen is going to have a -3, which one is it in? 5A. Okay, look at your periodic table. Sodium will be in group 1A. So that tells me that sodium has a +1. Nitrogen is going to have a -3 when it becomes an ion. So if I got a 3- for a nitrogen, it's going to take 3 sodiums in order to neutralize that negative charge. So that's why I have to have 3 sodiums in this formula. So write the ionic formula of the compound formed with barium +2 and chloride. Okay, so barium is a 2+, chloride is a -. Okay, so I have 2 pluses. I need 2 minuses to make this neutral. So what I'm going to need is what? 2 of these negatives. So that tells me that in the formula I'll have 1 barium and 2 chlorines. Now, if you were at my review session, what I said was if you have barium, which is in group 2A, so that we know that's a +2, and we have chlorine, which is in 7A, which is a -1. A quick and dirty, if you will, way to do that is that the 2 will go here, the 1 will go there, okay, which gives you BaCl2. So that's the quick way to do this. And so this is going to just describe for you how this works, okay, with the charge. All right, so we know that the charges have to equal out 0, okay? So what I typically do is I use my quick method and then I check it to make sure that it's correct. So if I have sodium, which I'm telling you is a +1, and oxygen is a -2, that tells me that I'm going to have Na2O. All right, so O is a -2 and sodium is a +1. Okay, so that gives me a +2 and a -2. All right, so that'll give me the 0 charge. So that tells me that this one is correct. So put me on pause and do these other 2 and see if you can do them. All right, if you've paused me, welcome back. And so now I'm going to look at this. I've got a 3 here and a 1 there, so I'm going to say that it's AlCl3. All right, Al has a +3, therefore it's going to take 3 -1s to neutralize that charge. Magnesium nitride is going to be Mg3N2. Again, all I did was what? Do this and do that. Okay, and so Mg3N2 is what I'm saying that answer is, and I'm saying AlCl3 is that. Magnesium is plus what? 2. Nitrogen is a -3. In this case, I've got -3 times 2 is -6, and I got +2 times 3, which is +6. Okay, so the 6 and the 6 cancel, makes me neutral, so that tells me that Mg3N2 is the correct formula. And so I've left in the solutions from the book, and they're going to show you how those charges actually work. Okay, so the Na, the AlCl3, and the Mg3N2. Remember, if this goes too fast for you, just rewind it a little bit, or you can slow me down or speed me up if you have got this. And so that's the end of 4.2. And so for this one, just remember that, you know, if you've got an Mg, which we're saying is a +2, and let's say you've got sulfur, okay, which if you look at your periodic table and you've got them labeled, it's a -2. The formula for that would be what? Mgs. Why? Because if I went by my little shortcut method, right, like this, it would be what? Mg2s2. But I've got to have that lowest ratio, so that's why it's Mgs. So that's really the only little kicker to doing it the fast way. N, okay, that's a +1. N is a -3, so I know I've got to have 3 of those. Alright, so that's the quick way, but always check and make sure you did it right, because you know that you need 3 pluses to neutralize a -3. Alright, and so with this one, this is the exception, that if you get numbers that are divisible into each other, then you have to do the lowest common denominator. Alright, and that's the end of 4.2 in ionic compounds, and I hope you can either continue on with 4.3, or I will see you back soon. Thanks.